In here, I either have to take off my sweater or I don't know. Oh yeah, I have several layers. One layer too many. I just did a Spider-Man meme. Wait, here. Yeah, forgetting my bottles that are already open. Hello Johnny, hello Dutch, hello Deshipu. Yeah, we are live, that's good. Alright, so last time we opened the shipment. Oh yeah, you're asking if I finished my PCB. I finished one version of it. Stars in the White. Yeah. Never. We have to fix fix my life first. Here we go. That's the PCB. Let me show you the ground. Look the ground. Look the ground. Isn't that beautiful? It covers almost everything. Yeah. And oh yeah, by the way, I had several issues with the board. Let's run DRC. Oh, Christian, hello. Oh wait. Johnny and Christian just subbed. Oh nice. Is this hype train? Christian missed one, or Christian joined later. Nice. Thank you very much. Okay. Hello, Rohan. Hey, Jordi. So what was... full was not found. Oh, yeah. Wait a second. Did my... Yeah, my Google Drive just broke. As always, why is this app so crappy? Or do I have to update it somehow? Do we need to update Google Drive app? Yeah. Is my drive not working? It refuses. Let me kill it in the task manager. Oh, wow. Drive. Okay, I killed it. Now let's try again. Okay, so the footprint was only... Oh. Hey DHC. Thank you very much. Are those bits? Yeah. Wait, Mr. Destructoid 100. Let me check that. Yeah, Google Drive is running. All right, so impedance matching. I gave up here. Oh, Johnny, thank you. I only made like the grounds in between the lines somewhere and made them so they wrap around, but I just gave up at some point. I think it was... Oh, yeah. No worries. Hi, ITT. Are you feeling better today? How's your head? You should try Booster. Ice cold Booster. Oh yeah. Yeah, so I ordered it. It looks alright, has no issues. If I try again, let me run it again. Now it should be zero issues because I turned him off. And then I had to reorder because, yeah, DRC is now checking. That was the KaiGet version. I had to reorder because the first time I ordered, I had like until Sunday there was a coupon for $30 off for 6-layer boards. And I wanted to submit the order for that. And I submitted it, and then I paid it, and then they checked it, and it turns out I somehow caffeine. It contains. Yes. So it has taurine, a lot of it, and then caffeine. So just like Red Bull, I guess. How much taurine is it? It will dump poison. No sugar. It's sugar free. Absolute zero. There is no. Yeah, perfect sleeping pill for you. Yeah, for me as well. Sometimes it's like extra poison. Aspartame. Yeah, probably. Let me check. Yes, aspartame. The raw cancer. Yeah. Yeah, so I submitted the order, and then they sent me a message. I have to pay up like $15 because there are wires with 150 micrometer diameter, and I designed it to be like the second tier wires, 200 micrometer. Hey Kaspar, what I've been breaking today? We are breaking the light barrier, the light speed barrier. With enough booster stuff. Yeah, I didn't even care to make all those vias like that. So I canceled the order, and I fixed the few vias that were the wrong diameter. It was apparently it was a mistake. Oh, they are on top of each other. I was just wondering. Damn it! Is it not connected? Yes, it is. They're just on top of each other. Power distribution. I think I fixed a few things. Anyways, yeah, submitted it, and then I forgot to apply the coupon again, and then I had to cancel it again. Now I paid like 2 times already, $170 in total, and the third time is a charm. I reordered with applying the coupon, and now it's almost finished. They said it's 5 days because I didn't want a rush job. You pay extra for 6-layer if it's faster. Where is it? Order history. Here we are. Boop. Now I hope it's not showing my address or anything. Production progress. We are automatic visual inspection, now electrical test, because we have the flying probe test. No, not flying probe test. The whatever Kelvin, whatever test it is. So it should be shipping quite soon. Maybe tomorrow. Profile V scoring, final inspection. I don't know. And it was 61 euros. I finally switched to euros on that platform, so I don't have to mess around with converting dollars for my tax stuff. Anyways, I hope we get, yeah, I ordered it with a stencil, of course. So here stencil was quickly done. I hope I get it right. But I might order a second version. Look at this one. Here I cared about spacing of these so I can put vias anywhere in between. Hey TMK, I could place vias like here and it will still work, but in the end I just let me show you the actual yeah, these are the ground planes. We don't care about those. Actually, we have, if I turn off that, look at that. We never place any vias in between, so in between here, and we have like ground left and right. So it's a complete transmission line. If you overlay it with this one, they are just staggered compared to the other. What is? Ah yeah. Wait. Let me remove the silk screen. This. Yeah, they are staggered. The inner layers are staggered, so we have a transmission line, and we have on top of that and on below that we have two ground planes. Oh, you probably don't need AI will take over. I just got a request from a company that does basically AI PCB design software. You just put together the blocks like Node-RED, and then it will make a PCB probably for you. I don't know. Yeah, will never happen with 4-layer boards. Yeah, won't happen. They will be just a little bit thicker then if it's on 4 layers, because the impedance has to be strip line impedance calculations. We can check that. I know for most of the people this is like really annoying or not interesting. Paint and acid, yeah. Microstrip, yeah. Microstrip line is that. Either that or it's just a coplanar, so there is no ground planes. That will be the configuration if we do like 4-layer boards. So in this case, if you calculate, like analyze it, wait. 57 ohms, the width will be 1.5, and then this one here, actually, I don't, where is it? Not coupled. This one here, yeah. Strip line. Yeah, it's a little bit low impedance, less noise. So yeah, it's better to have like extra planes, but it's not really. It's probably better to like enclose it, especially since we have PWM LEDs on top of it. If you have like the stack up, the cheap stack up from JLC, let's take a look at it. We have impedance matching here, yeah. So the cheap stack up is this one here. You can see that top copper, and this is where all the PWM LED stuff is happening, power and whatnot. We have only 100 micrometer dielectric between the second layer, which would be the signal layer in that case. I mean, okay, this is the six layer version, but let me check that. Yeah, you have like 5 times the thickness between those two layers. So I have now ground here, signal, signal, ground. So actually, yeah, this is still very thin, but with the staggering in between, let me check. What would be the thickness? 1.6. Okay, and layer, signal layer, let's say it's 2. Coplanar signal, yeah, I can't change the reference here. I mean, there is no reference. Yeah, the thickness of the line has to be 1.7 instead of 1.3 on this calculator if we do it like that. But I see now we have like 200 micrometers. Yeah, but there is 1 millimeter in between those two. That's terrible. We have like 200 micrometers to the noisy plane. In this stack up, probably there is a different one that we can pick, but they are quite costly. Anyways, I ordered with the 6-layer one, with the design that we picked now. Letraset, what is that? And this is the new design where I thought if I'm staggering them, I can make them even closer, but I could, because I don't need to put vias in between or vias on top of each of the lines. They're still staggered. I might put more space, but look at that. That looks like way less messy. Not sure which one will perform better in the end. But if we take a look at that. Oh yeah, you need to, the PCB ends here, so and these are the extents. They're quite full. The distances are high, but this part is quite messy, and of course there's stuff like that we can avoid, like this power is moving around here and so on. And on the design, the new design in Altium, I have them closer, but Altium also calculated different impedance. Look at that. Let me turn it on. So the impedance calculation, oh yeah, I made plane second, third, fourth are the signal, and there is a plane again, 5th layer. Oh yeah, sorry, it's very tiny. I don't know if I can zoom in somehow. And we have in a layer, this is the oh shit, wait a second, clearance, the clearance is 100. That's why I got a different thickness. Ah, Oh, now we have this thickness. Okay. Covering. What is C1? What is that? C1. That's the thickness of the copper. Yeah, that's given. Okay, yeah, that's why I had different calculation here. Okay, that makes sense now. Yeah, all right. That's good news. Clearance. Okay, they're symmetrical. So, what Altium does now, we have like a different width on the two layers. I can't zoom in. Can I zoom in somehow? Let's take a look at the board. Okay, now this is wrong, but can we fix that? Do I have to reroute it? Okay, inner layer. 1, 2, 8. Let's try again. Okay, so let's try here. Let's try to route that. Okay, do we have 1.4 is the width that it says. Do I need to change that somehow? 1.4, why is it still 1.4? Do I need to apply somehow? It's weird. Oh, wait. Yeah. This is of course terrible. Let me check rules. I don't want to bore you too much with, oh, look at that. Okay, it's marked red because they're not matching the profile again. Here, okay. Now I apply and it will automatically switch the size, which is really cool. So now it shows, of course, the error. I'm not sure if I can fix it automatically. Let me check that. If it will... Okay, let me check that. Switch and right mouse button violations with constraint. Highlight jump, wave this violation, okay. It shows me that it's violating. Either I have to reroute or to fix it with some rule or some badge. Let me. But this is why the calculation was off for the impedance. Now let's try. I just wanted to show you how it's switching the sizes. Okay, let me move that. Okay, so now when I switch the layer, the size is thinner. Look at that. You see that? And if I switch to back plane like that, it's thicker again, as thick as on the first signal layer. Yeah, this is how that works. Okay, now I know the task. Now, yes. I have the marking. Why is my impedance calculation not matching here? This was my task. Resolve. Was wrong. Okay. I will add a new task to that. And then we will test the LED. All right. Comments and task. And let me... Not this one. Do I have rooms? Tracks. All right. Here we go. Fix CS line. Assign it to me. Here we go. All right. Okay, let's leave that. We get some more space and some more clearance when we switch those. So if we would do that and then switch properties. I automatically switch. Does anyone know if there is a way to batch adjust the width similar to this? We can filter, find similar objects, track, same, layer, net, any. Is there like net class? Let's see net class here. Okay, we could do same layer, any objects here, because we don't have any other things changed. Now, what was the calculations for that? We had this one here. Whoop. And now it's fixed. And then also that. But I would need to change the other find. Yeah. Layer, same. Okay, and fix that. Alright, the violation should be gone now, except what's with that one? No, I will on the other one, on the KiKit version I will. This one I will. Because none of us ever have to use Altium. Would you have added like, yeah. Why is this still marked? Violations. Min, max, preferred. Yeah, this changed. Not sure what the issue was. Anyways, I push to the server and be good. Okay. Anyways, let's try to do something else, and this will be the LED here. Hey, Thomas. Yeah, no, it's not the same. This is the Altium version. This is the Altium version, and this is the KiCad version. The KiCad version is ordered, and it's almost finished and almost shipped. And I have just to build it at home. The other one I will order assembled to see how well that works. If it doesn't work at all, I might change the LEDs because look at the size of the LED. That has like four pads, and I have to somehow place them correctly here, like next to that, or like if the PCBs are assembled. Yeah, it's an LED 4 ounce. It's certainly smaller than an ant. It's probably as big as an ant segment. Hey, Sonic. Sonic, I thought about you today. Did you enjoy watching Furiosa? I'm not sure if action is for you, but you liked the actress on still pending. I thought it was picked for. Yeah, yesterday I checked if I like what the tickets prices are for Avatar. It's like $17. Oh, this is like 34 Deutsche Mark for a cinema visit. I would really love to go to cinema again. But I have like with the Dolby Vision spoiled. Nah, please don't spoil me. Yeah, old people. This is a joke. I'm not calculating in my head. There are people in the chat who weren't alive yet when the euro was introduced. Could be 30 euros, yeah. All right, okay. Oh, I forgot to turn on the microscope. They're not real people. Rentenmark? What is that? No, I didn't. What is loop inductance? Because they're wire wound. No, they're like they're layered. Do capacitors have inductivity? Yeah, you probably can't get them like in values like microfarad sizes. Oh, that's cool. That's a cool project. I have so much components on my stock. I could rebuild like I don't know, whole computer, supercomputer here. I have plenty of MCUs. I probably have, I don't know, hundreds of MCUs here. All right, so let's try. Where is it? try to solder this LED. Okay, I will use my finest tip. Oh. All right. Okay. Here for scale, a human hair for scale. This is my hair. Okay, and basically in my design, I made like a trace in between these pads as well, with enough clearance. So we have at least 300 micrometer in between here. It's crazy, isn't it? Wait, let me focus correctly here. Oh, wow. I need to focus it for you though. Oh, lost it. Here we go. I will use my finest soldering iron tip. How do I even start? Oh no, I have no clue. Okay. How do we do it? I need the wires first. So let me get some wires. This is the thinnest wire that I have. Hot air. I might need more. The light is, oh no, it rolled. What LED? Okay. I need more lights. Closer. Okay. Let's get, how do I even start here? Let's heat up the soldering iron. Should we give it some flux? Here is some flux. I have no clue. I will put it to 300 and ah! Look, you can see like from the side how it looks like, the body and the diffuser. Okay, now we need some solder. So let's get some of the good stuff. I need to put the solder on the tip of the soldering iron, otherwise it won't work. Yeah. Ah! Wow! That worked better than expected. These are my finest tweezers. Do you see the hair here? This is the hair that my hair has. Yeah, I'm not heating it up for too long. Even the flux keeps it in place. You're worried too much. You're worried too much. Let's try and see what happens. We are here in hobby. Oh shit. How do I get my enameled wire clear? Foo! Ah! Maybe I will prepare the wire first before I do anything. Okay, let me get the wire cut first. Huh? I cut off a wire and now it's gone. Okay, I need like 4 wires of the same width. I mean length. Yeah, you were a professional for too long. Who's messing with the RP? No, I'm not messing with the board. That one I had to put aside because too many simultaneous projects and it wasn't working right away, so. It will probably be good, but I will try to. Ah! Everything is rolling around. What's going on here? This paper is moving too much. All right. First one is on. If I get the second one, I can pin it down a little bit more. My microscope is at the highest magnification right now here, so. I just noticed that even at that scale, 180 degrees is still 180 degrees. Hydroscopic. I think this is not phosphorus or anything. And the phosphor. Oh, what is happening here? good enough. Here we go. Second one is attached. Now this one can't fly away anymore. And it can't turn around. Yeah, Twitter is just like MySpace right now, huh? I don't know. Ah! Wait. Okay. We have 3 wires on. I think it won't be an issue assembling 65,000 of those. What do you think? 64K of those LEDs? There won't be any issues. Look how easy it was. Yeah, since Elon bought it, Twitter is just gone. I should remove it from my links. I was not really using it. It's quite bad because I had a little followship there as well, but now Mastodon isn't as good, or let's say I don't have like this reach. There we go. Oh really? I should maybe do it. I mean, I'm on Blue Sky, but how do you authenticate it with a record or what is it? Or you send an email? Text record? Oh yeah, that's cool. I should do that then. Okay, I'm attaching it to a pin header. Oh shit, it dropped. Which one still needs stripping? Which end of it? Okay, we can zoom out a little bit. Okay, this has some stripping. This has the last one here. I bet we really can't run it at high power to not overpower it. I mean, to not desolder the wires again. All right, so let me get. Maybe I should bend the ends and hope for the best. Oh, it collected some dust here. Yeah, probably. We can do that. Wait, where's my blue tag? I have a blue tag. I should have used it before. Here. I will just get this end. So let's get 4-pin header. Like that. Whoop. So where's the marking? The marking is here. Oh, they get like JC usually has like regularly some coupons. Now I need some excavation maybe. If it's even on here. Excavation, I mean. Fuck. Where is it? Too much fumes here. Okay. There we go. Okay. So this is the first one, I guess. Second one. Third one and fourth one. All right. It's still at 700 plus the 2 from the last sponsorship, but we're halfway there. After the ultra cluster is finished, I will have enough cash for the excavator. Here we go. Look at that. It's a little bit dusty. Whoop. Now we can test it. Oh, it's so much dust. Right, this is 1 square millimeter. Oh, there is a plug-in that you can use for JLC. It's quite easy. You can, yeah. I don't know what's the name is. Have a good meal. Here we go. Let's power it up, shall we? Oh. Ah. Let's get the PSU here. Oh, so big. PSU is so big. Big and chunky. Let me get more light from the back. Oh, this here, this is my day job. I do only YouTube. Probably couldn't afford to do YouTube if I was paying rent. Yeah. I get quite good sponsorship. Whenever I do a video, I get well paid. So that's that. Where are the jumper wires? Here we go. Okay, let's plug that in. Okay, let's find. Yeah, you should. I mean, didn't you retire? It was you that retired. Oh, Kaspar! Excavator. Or beer for all night. Let me put this on in the excavator fund. Where is the excavator fund here? Thank you very much. That's like 25 bucks or 20 bucks. Wow. Thank you very much. Here we go. Desktop. Casper. PLN 100. Wow. You wanted to buy you something, didn't you want? Oh, what was that you bought yourself for Christmas? A new PC? Were you able to get like affordable RAM? No, you bought it already before the RAM skyrocketed. Tell me about it. Oh yeah, 24. Okay. Wow. Okay, that's a lot. The zloty is way stronger than it's currently, like, really good. 24. Wow. It's actually 24 euros. Wow. Here we go. Uh, let's try the LEDs now. Here. Let's run it at 12 volts, 1 milliamp. Voltage, yeah, I don't know. Voltage should be alright. Current. One milliamp. This is our oh no! Damn it! RAM. It will get worse with the RAM. Tell you that. You need to wait for the AI bubble to burst, and then we will get some nice GPUs to buy for cheap. Imagine when the AI bubble bursts. Probably there are companies that are using regular graphics cards. Okay, you can't see the LED, but it's here. I'm pointing at it. Okay, let's turn it on. Let's turn it on, my dudes and dudesks. On. Nothing. Okay, maybe that's the wrong pin. Oh, wait. Here we go. Yeah, we have a... It's a bad connection here. Which wire is bad? This is a red. This is green. Green is quite bright. And this is blue. Still working! Not overheated. Alright. Okay, let's give it more power. Huh? Oh. The bad wires are the issue, not the current limit. Here we have 5 milliamps. Which one is it? Wait a second. And this is shitty wires. Give me better wire here. I hope this one is better, otherwise I will just squeeze it with pliers. Ah! Ground. Okay, here we go. No. Is it? Okay, here we go. Test. Test. This is 3 milliamps. And test. 4 milliamps. Ooh. Okay, 2 volts. Oh, nice. That's quite bright. Quite bright. In it. Blue. Blue is 2.71 milliamps. So if we need to increase the voltage, 3 volts. It needs to be 3 volts for it to draw. How hot? Can feel it. It's. I mean, how hot is it? You can calculate. That's 10 milliwatts. Red is always more. No, blue is more voltage, yeah. So if we switch, blue is the highest voltage. .7, and this is 2 volts, yeah. So we need a supply, since we have a common anode. We need a supply of just read the data sheet. No, we read the data sheet. That's perfectly fine. We are current limiting to 4 milliamps, and the data sheet is basically telling the same story. I will probably make the power supply for the LEDs, since I need to go with the highest voltage. Unfortunately, common anode here. So for blue, and we want to run it probably something around 1 milliamps. So we need like 3 volts, because there is a drop across the wires as well. Yeah, I know it doesn't like 3 volts, but look at that. It's only 2 volts here. It's limiting to the current, and we have a current limiting resistor there for red, so it will never exceed 1 milliamps. Here we don't have any resistors because we have current limiting in the power supply. But this is cool. The LED is quite neat. Let's zoom in and look at it. Look at its beauty. Hey, Kaminzen! Happy New Year. Here. Look at this LED. Whoop. Here we go. Filmed in HDR. What? Oleg, is it you? Spider leg, yeah. Cool. Nice. Let's do the current here. Ten milliamps. Yeah, it's way more efficient at low currents. It looks like at like 3 milliamps we reach quite a good brightness, like 5 milliamps. More juice. Ah, uh, we need higher voltage here. Blue is quite bright at low amperage. Look at that, 1 milliamp, 10 milliamps. Oh, that looks cool. Okay, and red, we had red. Green is also quite bright. It's basically blue with phosphorus. Oh, we were running it at 3.3 volts. Nice. Infinite power. Yeah. Yeah, it's RGB. The red looks really blown out on camera. It's really red in the real life. Also the blue, it looks almost white in the hotspot. But I'm filming in HDR. Oh, that's a cool image. Oh, I have a movie recommendation for you peeps. Whoever likes Alien franchise and Predator franchise, the new Predator Badlands movie is a lot of fun. I liked already the previous one. Uh, the one before were like not that great, but like the Badlands Predator, the Predator Badlands was really enjoyable. It had a lot of fun, let's say fun elements to it, not very serious. Oh wait, what does IMDb say? What's the rating? 7.3. Yeah, that's deserved. I would say it's not rigged. Like rating for 7.3 is quite genuine. That's cool. What does Metacritics say? Metacritic. Favorable. User score. His eyes looked a bit off. Oh, You won't like it. The size of the vias is like the drill diameter is 0.2 and the ring is 0.3. So that's only like very narrow vias. They will probably, the ring won't be like perfect everywhere. But these are the limits for JLC. Could probably make. Oh, you mean the face of the predator? Oh yeah, I know what you mean. Okay, yeah. Like you mean the prosthetics in the end? No, it's not beyond the capabilities. I did it before. Hey, Maury! Uh, wait, via diameter. Here. This is the minimum. So via diameter is basically yeah, the ring is 0.5 in that case, or 0.05. Minimal hole size is that. You could probably, yeah, no worries. I was also surprised because if you look at that, usually minimal trace width is 0.09 or something on the top layers, bottom layer, or like what you will see is in the caps where it traces here. Yeah, you have always min trace width. Wait, two layer. Wait, features, traces, description. Track width here. 0.1. There is multi-layer, it's even thinner. That's higher, the higher copper, even higher copper, and even higher copper. The higher the copper, then they need more tolerance. So the highest restriction is this one here, not pad hole spacing. This here, 0.2. You're right, power because the traces were really thin and not many here, but I will show you how this. Yeah, it's still close. Yeah, it's close, 0.2, but yeah, you can see track to hole needs also to be 0.2. So you have like ton of room not wasted because of that restriction. Basically, the hole to. Hey Fu! Happy New Year to you too! Basically, everything is dictated by the hole minimal hole diameter that you're using and the hole to copper spacing. LED is still glowing. Still glowing LED. We have a ton of ground vias here. So we have always a back track. I don't know. Thicker layer you need. Oh yeah, by the way, my power on this design here, you can see this is just this is not the actual final one, this is my test design. For power I'm only using top and bottom layers which have thicker copper, and yeah, the copper width here that's for the LEDs. This is for the MCU. Okay, the bottleneck is probably this one here. It's 0.3, I believe. 0.3 millimeters is. This one is higher. There are. This one is probably 0. No. Oh wait. 156, okay. 0.3. My my new design. Wait. The new design, I will put a copper pore, so there is always 0.3 millimeter tracks here. 0.3 for the power. There are bigger, or no, there are more ground pads, and I will probably put even more there because I put all the traces on top and bottom, and I have plenty of space here. So I can either use bigger vias or also maybe route the clock not underneath it. Yeah, so here 0.3 and copper pore for, let me show that, tools, polygon pores, restore shelved. Yeah, let me, oh, need to, the solution for no, I need to re-pour everything. Design, wait, I need to use the hotkeys. Tools, wait, tools, no, design, no, tools, polygon, all, here, report. Okay, so my idea is to basically, where is my bottom layer? Put everything on the bottom layer, all the powers, and they will be traced like that. Okay, here, this is obviously not working. No, not a super tiny. Wagon loads. It will be the ultra cluster. So I will change this polygon basically to trace, to supply. Let me do that. Repour. Still interrupted. I might to route it though. There is nothing on the bottom, or I will use a reference plane for the MCU power. Like that. There are only 2 power levels on the bottom layer. Oh no, it's too dense. No! Too many. Oh no, too many vias here. Let's see if I can fix that. Wait a second. Ah, next. Here we go. That's the issue. I need to do obey rules. That's my rules here. Here. Report. Yeah. So we have plenty of current transport here, and the only other thing that needs to go there is a second pour, which will be the LED power. So I have one power for. So who is an actual engineer? If I have two power planes in my stack up here, I have the plane here. Wait, I have a ground plane. First in a layer is a ground plane, and this layer is another reference plane. Can I put like just the power for the MCUs there? Died of a heart attack long time ago. What? Yeah, I'm just wondering. I mean, it's a reference. I need your input. You people who studied engineering. A reference plane can be either ground or VCC. If we use MCU VCC for that, that should be alright, should it? No? Christian, what do you say? Sounds like a capacitor. Oh, yeah, you're right. There will be a huge capacitor. I can just remove all the caps. Two parallel copper planes act as a capacitor. So what's the capacitance? Can someone calculate it? Hey, K-Mans, I can show you the LED that I was testing before. We can just remove all the caps. We have big planes. we need to calculate. I will give you. Please don't buy them. I need. What? Also, I'm still alive. You people are worrying too much. I would say you're worrying too much. We are here to have fun. What would be the life? I mean, people are bungee jumping. I never did bungee jumping. I mean, I did paragliding. Here, this is the LED. Nation star, blah blah blah. 1 times 1 millimeter LED. Here we go. Here's the LED. Good luck with that. It's way too small. Maybe we find a bigger one that we can fit. SMD. Oh, actually, there are bigger ones. I can maybe use that one. Xinglight. I used Xinglight before. The Xinglight was only hurting in my eyes. Red. Wait, I need RGB though. Greg? Oh yeah. Sick. I'm not sure if JC would be able to assemble that. Oh, he let it assembled by JC? What spacing does he have? Like what's the clearance between the... Oh yeah, I have a cap meter. I could do that. Low temp solder paste, a lot of flux, and then using the pixel pump. I need RGB though. Yeah, love that. Okay, wait a second. Where are the RGB ones? Do we get emerald green indication, yellow, green, white, white, red? Okay, you know what? I will just use... Oh, null, 0, nothing in stock. Okay, let's clear it. I have... We picked some good audiobooks. Why is it complaining? What's the violation here? Polygon not repo after edit. Yeah, okay. Repo it. Wait a second. Which one is that? Oh yeah, we changed it again. Here we go. And what's violating now? Cross probe. Maybe Altium could calculate the capacity. Trying to reconnect anyways. I'm wondering if I should fix the spacing here somehow. Maybe I will change a little bit the placing of the ground vias to the center. Could move that like... Dielectric constants. Okay, we can do that here. Okay, we have, let's say this is layer, bottom inner layer, and 0.55. So let's assume we have complete ground here. Oh wait, no, we have this one here. Oh, bottom layer is different. Okay, let's take this layer here and assume on the bottom we have ground as well. This is the narrow thing. The area in square millimeters. Okay, let me check. On the whole PCB, that will be 32 times 8 times 205. That's the square millimeters. Times dielectric constant is 4.1. times 0. Very specific, 0.885. It's just like Planck constant or something. Divided by yeah, 0. I would say let's round it up to 1. 0.1. That's picofarads, or what is it? Farad or picofarads? Oh, picofarads. Okay. So we have only 90 nanofarads. That's nothing. That's nothing. There's no capacity whatsoever. And between those two layers, it's even less, because that's five times divided by, yeah. It's only like, in total, it will be like 22 nanofarads. It's nothing. Or did I do the calculation wrong? Foo. We have 205 millimeters by 8 times 32 is by 255. Like 60,000 permittivity adjusted for millimeter and picofarad units. Yeah, but I assume, I mean, it's some sort of constant that will at some point break down to Planck constant or speed of light or something like that. Some odd constant, like natural constant. It's not like a random number, is it? We are not transforming to feet and nautical miles. Just to be fair, I mean, we use nautical miles in Europe as well. All right. Yeah, that's no capacity at all, peeps. I thought we could save on the capacitors here, but no, we can't. I can close that one. Did we save already? Does it complain to save? Yeah, save it. You can save everything. Ah, lab voice. Epsilon 0. Okay, let's... And the U gets longer and longer. Foo grows with time. Just place both planes on the same PCB side. Okay, where's the icon? How does Planck is with CK? Planck? Planck's constant is tied to both C and Planck's constant deeper structural relation, deeper directness, okay? What is mu? Vacuum permeability and vacuum permittivity. See. Oh, look at that. There is a relation. Is this correct? Yeah, that's basically like Casimir effect. No, Casimir effect is the... Oh, no, wait, sorry. Casimir effect is the attraction of two plates because we have like the annihilation and only certain wavelengths can create between like in this distance. So there are more particles created, virtual particles on the outside of the plates, pushing the plates together. Oh wait, do we get... We don't need to glue the PCB layers, they will be just held together by the Casimir effect. Breakdown. Yeah, voltage breakdown is low. Yeah, you're right. All the icons are gone. What's happening here? Rearranged, okay. Look at that. Look at that. Look at that. What is alpha? Does Casimir know? Caspar knows, maybe. Casimir and Caspar aren't they the same? But I had the impression like this is just Euler. We have Euler, we have epsilon zero, Planck, and it's weird. A 0-point module. We can build a 0-point energy. But it's interesting. Like everything has some relation to Planck and ZP. Yeah, in German it's ZPM. This is still working. Oh shit! Oh, that was something else. I dropped something else. Sorry, I needed to... Okay, anyways. Sabina? What is Hemsdorfer now? What's her name again? Sabina? Does she still do videos? I mean, she talked about everything at this point, didn't she? Capacitance value is in... Yeah. That's basically right. Or the thickness of the dielectric material. But what did we get from reference plane? I mean, how would it... If we have like a strip wire and one side of the strip wire is the ground reference and the other side of the coplanar copper is like ground and the bottom layer, like the reference layer, is VCC. Does that still work or is this like an issue? How do we solve that? It's directly proportional to the awesomeness of the project. Yeah. Oh yeah, this. Someone asked. Can I reconnect? About. As I open it in a different. Yeah, now you see my password here. It was flashed on the screen. So, for those who didn't, you can see there are like 64 PCBs. This is the board, and basically this section of the board is what we see here. Wait, maybe we can we see in 3D? Oh, nice. We can see in 3D. This is how it looks like right now. Can we rotate? How do you rotate in 3D? Oh, nice. Yes, basically a Cray computer, but way cooler. Each of those MCUs has more calculation power than the C64. Beautiful, yes. And each of those has an LED, but it isn't shown here. I need to make a model to display the LED. And I had to place it symmetrical. So all the LEDs and the MCUs will be placed equidistant to each other. Not that this row, they're sharing like one SPI, single-ended SPI here. Whoop. And there will be basically another one rotated by 90 degrees here, and this 16 times, because we have 32 rows, 16 times on top of each other, and these are 16 millimeters across. So this is it. All right. What do we do now? We did this is the LED. I won't be able to place that. How tiny is that? Okay. Just for size comparison. Wait, I need to show you size comparison. I have a paper clip or anything. Okay. Here. SD card for size comparison. So like this fiddly write protection at the side is like 3 times as big as the LED. Phew, you missed that. Each of the MCUs will have an individual LED here. We have 64K LEDs. We need like on each of the we need to know if it's working. So we need like 1 kilowatt of power just to, or like 2 kilowatt. DNP3 protocol, what is that? Distributed Network Protocol is an open communication standard for SCADA, supervisory control and data acquisition systems widely used in utilities like electric, blah blah blah, Mr. Freeman. You know the meme, blah blah blah, Mr. Freeman? That's a homage to Half-Life 2. Yeah, we can use that. We can use that, your protocol on the distribution. The final carrier. Oh yeah. Wait. What did you see? Wait. Where's the? Where is it? Where is it? Where is the on shape? Here. Yes, this is the part that we designed is like these two rows here. Half of the line, these two rows is basically that what we designed. So this is a test unit. What I ordered is just the test unit. Gigawatt orbital Ferris wheel. 64 modules in total, arranged like that in an acrylic container. We don't know if it will be submerged cooled because it's 3 kilowatt, or very efficient air cooling. It's very narrow. If you let me activate it, unsuppress. It's quite tight already, like here. Look at that. And it's quite close to the wall. There is not much air, and these are already 20. Yeah, very complex room heater. We just want 1 MCU per pixel. We'll get 1 MCU per pixel. And I want, that will be only QVGA, but still. This will be actual Mandelbrot in HDR. So many MCUs and like 100 frames per second, maybe more. I don't know. Crisis, Doom. The issue is, can it play Doom? We need like to distribute. We have like 2,000 of these MCUs. Oh, by the way, here did I show them already? The other MCUs here. These are the host MCUs. They are quite cheap, but they have a FPU. So these are the controlling MCUs. Finger for. Oh, and there is the tiny core. So one of those will control 32 of those here. So we have 2K FPUs. The small ones support integer multiplication and division. Oh, cosine! Thank you for the resub. And Happy New Year to you. Here is a nice LED just for you. Whoop. Dusty. Can it play? Wait, where is the gameplay? Is 0.5 milliseconds on 33 megahertz ARM 7. Game logic. Okay. Yeah, we're faster than that. But we need like, the problem will be rendering, like the distribution of the rendering. We can't load the textures on the MCUs. Like the texture filtering would be needed to be done somewhere else in between. I don't know. How big are the textures for one level of Doom? What is it made for? 1 megabyte? 2 megabytes? We don't have that. Let me check the data sheet. Production. Were created for this reason. Yeah, FPGAs. If you, my opinion on FPGAs is we did FPGAs on this channel already, but it's such a complex world. You can just dive in and never come out. It's like a rabbit hole. Like taking the what pill is it for Neo? It's quite hard. Okay, we are which first product description? We have 256 kilobytes of flash, 64 kilobytes of SRAM on the bigger ones. Why did my chat break? My chat break. Can't hear the chat anymore. Interesting talk on CCC about FPGA virus scanners. Yeah, it's just Chrome messes it up. I need to switch to Firefox again. It's annoying. Okay. Can we get a test? Okay. Lettuce. Oh, you mean like, does it have, Thomas, you're onto something. Which one would you suggest? I don't mind switching these here, but I really wanted some FP. Yeah, but ICE40, we can't fit like an FPU in there. So what I wanted to do, I wanted to have these here. I mean, we can leave that stage, but in the end, I have a problem with the bottleneck here. We calculated there will be a bottleneck. I mean, you're new to basically to the streams. I put one here basically, so this is an SPI hybrid, a parallel SPI hybrid bus. That is fast enough. But then we get already a bottleneck here and from here to the main MCU and so on. So what I see a problem with this one here, which could be replaced by an FPGA, but we need at least 32 lines. So ICE40, let's see. That's a nice idea. Otherwise, I would take a Raspberry Pi Pico for that. Alright. Oh, BGA. Ah, you're killing me. 13 bucks at Mauser. Oh wow, that's expensive. I mean, you could do this also with, I think RP2040 with the PIOs would be fast enough to handle everything, but I'm not sure. This is just the next level. Okay, ICE40. Tang Nano, yeah. But oh, I don't want to use RP2350s. They are so messed up. We did one board here. Here. Where's our attempt? This is our RP2350 attempt. They're not booting. They're not I have no clue what's wrong with them. I put it on hold. RP2040 are proven. I think it's the newest one. The B version. No, wait. AB are the different pin counts. It's the newer silicon version, but they have really issues to start up. I have no clue what's wrong. Look at that. It's a 4-core. If that would work, that would be nice. Is the files for it available? Do you want to see it? Might be. Let me check on my GitHub. Repositories. No, I don't think I uploaded this one so far. Nope. Not yet. They have like really restrictions what kind of whatever crystal or inductor and stuff like that. They are so picky, so like snowflakey. The RP2350s, and I know I have like boards with 2040s that are working, that are proven to work and are like solid. Oh yeah, Fu, that already happened. This is what we are doing here. You're late to the show, mister. The production, maybe it's even updated now. Here. It's profiling. Electrical test passed. It's profiling already. Fu. Look at that thing. This is like you see the silk screen ultra cluster level 0 V1. Level 0 is basically the lowest level. Then I will order an assembled version. No worries. I will reorder maybe a version where with Alcium. I don't know. Usually they would be able to upload over over USB. It's profiling. Yeah, profiling. uh, all right. So this is like the first version. I just want to have something for us to assemble by hand and quickly test before I order. Like, I mean, this assembled version will probably cost me. Yeah, but you have like two powers. There is like 3.3 volt and 1.8 volt. What I did, maybe I can show it. We 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 are chit chatting here anyways. Where is it? I think this is the one. Which one is it? Cluster A cluster. Foo. Let me check that. Yeah, that's what you need the inductor for. So if you here, yeah, 1.1 volt. So the regulator, the switching regulator that needs that special polarized inductor, that's for the 1.1 volt core voltage. And what I did a completely external 1.1 volt here with caps, whatever, and supplying it just with 1.1 volts, not using the internal switching regulator, because that wouldn't work as easy. And this is basically the design. Why isn't it? Why aren't they filled? Where's my copper? My copper is gone. Help! My copper is gone. I don't know why it's not showing the copper here. Did I switch it off? Ah, yeah, here, the pads. Oh, wow! I didn't know you can turn them off. That's cool. Okay. Yeah, I tried hard. We couldn't even make. Okay, I should maybe try the Pico 2 boards. We even bought different boards without the USB, and we couldn't run them either. So I no clue what's wrong with that MCU. If it's so hard to make it run on its own, why should I take the risk to put it on a $15,000 project that would be like gross if that wouldn't work on the final boards here. So if we scale it up, we have like this. API 2040 might be. How many GPIOs, PIOs does the wait, I wanted to browse. By the Wi-Fi? What? How can you do that? Where is... No. here. We wanted to check integrated circuits. Okay, ice. Oh, $7. Okay. I mean, if we need it twice per board, 64, that's 128 times 7 is like $1,000 only for the MCUs. But this pricing is gross. They're probably cheaper if you get them bulk or whatever. Oh wait, they're like $1 if you buy them like that. Do they have internal flash? How hard is it to program? BGA, alright. Let's enter that. I just want to see the specs here. BGA, QFN 84. Quad flat pack. Okay, let's see. Oh shit, that's expensive. Yeah, $4 time 128. We are already at $500 only for this MCU. That's or for non-volatile RAM. So you need an external flash for boot up, huh? Let's see. Yeah, I know, but some I think there are FPGAs that have integrated flash. Do they? Wait. Okay, let's make it work. Memory SRAM pins QFN. Wait. Where are the packages? Family. That's ICE 40 Ultra Plus family. Cluster Schnipsel, yeah. Altera Max 10 on chip flash, yes. Micro Semi Pro ASIC, Lattice. There was a recent video on the CCC channel for the ROM and safety of RP23. Alright. I'm not worried too much about safety, I'm worried about functionality at all. Or is it physically breaking? What kind of safety do you mean? Fabric for intercommunication between MCUs. Yeah, I'm wondering if I can basically digest all the information. I can just use off the shelf, like on the main board. If you look at the whole cluster thingy here, they are plugging into a main board, and I'm getting a lot of buses coming in. Like each of those, there will be like 128 lines of something, and it will be hard for an MCU to digest that data. That could be handled by an FPGA. I can see that we don't need like to um, save like on money on that, because the count is one, or how many I will need up there. But on these boards we have 2000 of those here. That's why I'm taking one that costs 60 cents on LCSC, but I can get it cheaper. Yeah, yeah, I know they would, but they don't have like, either I need to put a 417 on, like two 470s on each of the boards, and it will be quite tight, or I use like a different connector here. So I could digest that, and the 417 has an actual parallel bus that you can use. It depends. Um, have you been on the stream where I try to explain how it will work? Okay, let me put into the layout. So what's happening here, let me do this. We have one SPI, volumetric POV. Yes, you could do it, Squirrel. You could, I mean, it will be 64K LEDs that are individually controlled. No, I'm not. I'm making a ultra cluster, but each of those MCUs will have an RGB LED, so we can do volumetric display. But there are more PCBs than. Oh, no, it's not rotating, or if you think like that, there will be actual PCBs. You can't look through that, but you can see from the side, so it will more or less look like that here. Cat. Make it spin. Oh yeah, actually that could work. Like spinning inside, so the centrifugal force would push the air to the side, and we just need vents on the border here, inlet and outlet. Yeah, it's not very good. It will have like only 1 GB of SRAM in total, so each core is limited. So Fu, the design is like that. We can either use SPI, or yeah, we have like 32 chip select for the individual small MCUs, but the small MCUs can use the chip select to basically write back data. This is one thing that we can do. I'm not sure though if these pins are as fast as I like them to be. We need to test that, because I know there were some pins on some MCUs that had like a lower driving force. Yeah, but then we need to bit bang it, because these MCUs don't support octal SPI. We could, let me check. Do we have? Oh yeah, there is no RGB here. 1, 2, 3, 4, 5. D0, D1. Yeah. we are missing now PB9. Ah, gross. Okay, it's gross, but we actually would have boot is also annoying. We have enough pins to have like an fake octal SPI. Yeah, FPGA. That's why I would consider taking PIOs or. Oh yeah, the 417 also has PIOs. I don't know how to use them. Mm, we. What is our FPGA thing? Where are you? No parity 7+1. Yeah, you're right. Do you need parity? We'll just calculate CRC. Yeah. SPI on boards are connected together. Transfer benefit to making and multi SPI boards. Now you can't do multi because we are using hardware SPI. I want to run calculations and transfer at the same time. And the host MCU has like 2 SPIs. Oh, GUIs. No, I like System Verilog. We did some stuff with System Verilog already here on this channel. The Go and FPGAs were quite cool. We can just use a Go-in FPGA board. Where is it? Do I have them here? Let me check that. No. Where am I Go-in FPGAs? I think they are downstairs. Ah, I hated this. Yeah, we have 3 SPIs, but 2 SPIs are like one SPI is basically covered by the CS, and I wanted the CS to be on on 2 ports, port A and port C, so we can read and write like bit bang really fast. So this is the optimal configuration, and we have one upstream and one downstream SPI. So here this is the upstream and this is the downstream SPI, or however you would like to call them. So we have actually 2 like the controlling MCUs. Here the controllers actually the communication can be run in the background over DMA, while these ones is doing like FPU stuff. We have 2000 of those, and this is fixed point or whatever calculations, integer calculations, 64K MCUs, and they can communicate while doing the calculations. So we are fine here. We just calculated that the bottleneck in data transfer will be between, like, if I have 32 of those, like 16 here, and oh, wagon loads. I don't worry about that right now. This is a protocol thing. This is a layer higher than hardware. I'm just worrying about the hardware, and we can figure out the protocols once we have this board received. So where is it? Where's my order? Whatever. When my order is back from JLC, which will be soon, hopefully. Where's LCSC, by the way? Can put it here. No. I lost my yeah, order history. Yeah, once this is received, we can test the protocols here. Yes, that's what I think. We need to scale on the pricing since we have like 2,000 of like on the PCB. Since we have 2,000 of these controllers, we can't go above like $1 per piece in total. That's why any extra component like flash, everything that's pricey like Maxes or um, anything like stacks really fast, as well as those here. Those cost like 13 cent if you would buy them from LCSC. Half of that if I buy it directly from WCH. In the module we have of the beefy ones we have 32, and we have 64 of the modules, so they are 2k 2048 in total of those here, which is already quite pricey if you consider that they are 60 cents a piece right now. So we are already at 1.5k $1,000 just for these MCUs, which are quite cheap. But we have 64 boards, so 128 MCUs, since we have on the left side and the right side. Where is the thing here? Nah, that is all protocol wagon. Let's care about that when we actually see what the bottleneck in the end is. I just need to 1 gigabyte of RAM for couple thousand. It's SRAM. Huh? It's better than DDR4. Directly tied to the core. Yeah, so we can actually take something better for it to unscramble all the data, process it and whatnot to transfer it to the center, and that will be 128 ones. Are we spending money? What are you doing around with today, kind? Yeah, we already spent some money for the PCBs, like $80. Now also on the MCUs, they are here. These are the beefy ones, 60 cent MCUs. Here. So little core, bigger core. This is our test tray. PCBs are ordered. We just need to assemble. The LED is here. These are the LEDs that we will use per core. They are drawing like 1 kilowatt in the end. Just running at 1 milliamp or something. 1 square millimeter big RGB. Yeah. Okay, so I wanted to check the pricing for, I don't know if LCSC has going. That's the lattice. How many GPIOs does it have? Elements, blocks. Drew, I don't know. I have the script already, but I'm worried that um, this project takes a lot of time. I really this I mean the ultra cluster will be still months from now. Where is the packaging? I wanted to see architecture, correct product family, general features. Is there ultra small form factor? No. Yeah, 307. We can use the 417 even. That has quite a lot of pins. Oh, we don't need that many pins. We just need a fast bus that's um me. Oh, I need to go to the. I need a toilet break. I'm not a senior electronics person. I'm a coder. Alpha. 144 is it's not the issue. It's like the bandwidth. Include still FGs. Yeah, it's for this. We are looking for alternatives, maybe alternatives. I'm repeating myself all the time. To process. Yeah. Z80, Happy New Year as well. Feliz Navidad to you and your family. To process the data that's incoming from, like we have 1000 MCUs here. These are 1000, 32 by 32. And we have like 512 MCUs. The data needs to be processed by one of those. I don't, I don't, I don't. How much of maths do you need? Oh, you need all of the maths, Alpha, Victor. If you want to study electronics, or I mean, even computer science is hard, but oh, like thermal dynamics, at least in Germany, breaks the necks of 50% of the people who are trying to get a degree there. Let's make a lot of MCUs. Yeah. Maybe I can share the calculation on that. Let me switch shortly so I don't spoil anything. Ultra cluster. Here. Okay, I will bring you all up to date. This is the last time for today. Okay, so yeah, PhD? No, not at all. I wouldn't even try. I have the master in computer science, but that's all. And a lot of experience. I'm already 46 years old. Okay, so we calculated the data that's necessary to. So this is the calculation that's per core. 20. Yeah, I don't have kids. Ah, yeah. Thank you. Yeah, this project will make me like 20 years older. Oh yeah, you remember ping pong? Yeah, I'm the ping pong guy forever now, and it's the least ambitious project ever. This is like imagine you're like a one-hit wonder in music. You did like albums with music that you're very passionate, and you did like one stupid Christmas song, Last Christmas or whatever, and everyone knows you only for that. That's how I feel with the ping pong LEDs. All right, so QVGA, we only need a transfer speed of, is this bytes per second or is it bits per second? Ping pong LED, what? Few madness. Yeah, the big one. The second one, I'm really proud. The third one is alright. I can't remember if it was bytes or bits. But the transfer speed, I think this is bits already. Smoke detector. Yeah. 120, that's bits. No, wait. 120, 36, that's bits per second. Okay, so. Yeah, the smoke detector was cool. Mega loads. That's a cool one. Okay, so these are. Oh, Transport Tycoon Deluxe. TDD guy. Okay, here. We did a calculation on how much transfer speed we need between the layers. And hey Hans, oh, Ultra Cluster. You need to rewind because I'm re-explaining everything like every 5 minutes now. Okay, so the transfer speed, like 500 kilobits per second. If we want to calculate something like that, 4K 12-bit HDR 120 FPS, that's like 500 kilobits per second per MCU. It's not the bottleneck between no, that's the wrong project. Sorry. It's not the bottleneck isn't between these MCUs and this MCU. That's not the bot. That's 500 kilobits per second with SPI, totally doable, because we can downstream in parallel. So when they are like fed with data, they can basically calculate something and then transfer the data back. I hope so, at least. I don't know. I mean, we need to transfer some data there per frame. But if we calculate like that, 500 kilobits per second, alright-ish. But then we have already the timeline for this project is 4 months in total. And Chinese New Year will be an issue because we can't manufacture anything. So I need everything, like the PCBs, everything assembled and shipped before Chinese New Year, and that's in January. And then finalize the design of the main board, or like the first version, so I can order in March, get it assembled and shipped, and then can build up the whole thing. But you know, big German projects that take like twice the cost and twice the duration. scared of. Why are you scared of electronics? You don't need to be scared. You can. People are making money of that without ever putting a foot into a university. It's a Arduino is. I started with Arduino as well, or I started with pure Atmel, but yeah, we went with ages with Arduinos, and now I'm stuck with stuff like that. Each MCU is individually addressable. Yes, they will be certainly, because they have like all an individual chip select. What's this LED? Each MCU has an LED. Oh, Thomas, you see, that's the issue with the Picos. Yeah, so we have a bottleneck of like 17. This is already 17 megabits per second is here. This is already this needs to process 17 megabits per second, and it runs at 144 megahertz, and you need at least like 3 cycles to store the data and then process it and send it even further to process it somewhere there. So we probably won't be able to do that, but HD is like 1/10 of that. That might be doable. Wait, that's 120. This is 6 megabits at this level here. So here through the port, 5 megabits per board. Per second, yeah. And QVGA, this is my goal, my entire goal. So we will certainly manage to transfer like 1400 bits per second from the little MCUs to the, and this is 1.5 megabits from the second highest level to the highest level, and then we have some USB. This is what we can transfer, 144 bits per second with the USB 3. No, USB 3 of that chip that I wanted to use supports 450 megabytes per second. Nothing. It is just to have one MCU per pixel. It will look cool, and it is the last one that I built. I will build never a cluster again after this one. Unless it doesn't work and I need to rebuild it. Okay, short bathroom break, and I'll be back in a second. You can watch this little LED. Should I switch to red? Let me switch to red. Here is red for you. Okay, I'm back. To mine Bitcoin or another money, nah, it's not worth it. All right, we wanted to redesign or the Intel Phi. Ay. NVIDIA drivers suck. Are we back? A new compact. No, it has nothing to do with that. It's just that NVIDIA breaks everything. I don't know. I had like a stable driver at some point, and all the new drivers suck. I get like a GPU reboot or driver crash. Interchip USB. Optimized by AI. Yeah. All right. Yeah. It's sad, but Altium also doesn't close gracefully when the driver crashes. Can't do anything. Need to close the window. AMD is just as bad. I'm hoping that my GPU that I make supercluster won't crash as easily. I need to task manager close Altium. Yeah. All right. Let me try to find my LCSC window. Here. Dutch Weeks? What? What is this title? Twitch dashboard stream manager. There's no Dutch Weeks. Since when do we have this title? This is long ago. No, casual making. I hope I... Dutch Weeks was when we had the actual Dutch Weeks. Damn it. I never noticed. I was preoccupied with managing the stream. Wait, we don't have Go-Win FPGAs here? Huh? Unsafe. Go-Win semi. I think this was little b. NR, that was the ones that we were using. Goldwing, no. Let me check if we can. rewrite firmware from scratch. Yeah. Who has the time for that? Where is my LCSC window? I lost my LCSC window. Huh? Okay, let's try again. Nope. They're not sold on LCSC. I don't know why. Ooh, Andy! Thank you! Thank you for the sub. Okay, Tang Nano. Why they are so expensive now? Yeah, Tang Nano 9K. They're using the NR9. Quite affordable. Low voltage 9 LV. Why can't we get those FPGA? Like standalone. Okay. Four I/O banks. That should be enough. Max GPIOs. And I/O bank is probably 8. It must be more than that. I think 19 are, what does that say? LVDS pairs. Oh, Hype Train! What? What is going on? You bricked a proprietary chip. What kind of proprietary chip? J-Link, yeah. It shouldn't be brickable. Stuff shouldn't be brickable. Oh no, it should have, because we have like for it doesn't like the Tang Nano they have already a lot of pins. And they have HDMI. I don't know if they are shared. You more. Let me check. Oh, oh yeah, we have. Okay. These are already 70, 80 pins here. So QFNs plus 80 pins, but we have like extra flash. So this is only external flash. And this is probably USB. One is USB, one is this is probably power regulator. Yeah, Thomas is happy. Yeah, that could handle, but why can't we get that might be a solution to fix, to get like an easy out on the main thing, to unscramble all the data that we are receiving. Oh yeah, wait, SRAM bits, does it have, it has, I think, PSRAM, external PSRAM or something, or internal PSRAM, which is really hard to use. we can also use the Prima 20K. It Yeah, here we go, Caspar. Here we go. Yeah, I have several of those already, so I can use those if I want to. They're fast. Okay. 1 gigabit DDR3 SDRAM. Casper, I probably want to like digest the data that we are receiving from all our panels, like the blades. Yeah, that's not much, but I have several of those. So, and they use like SDRAM slots. I have even like the board. What are the pin? Where are the pin? Okay, multipliers. Yeah, PLS SD display. Core voltage. Where are the GPIOs? User IOs. Okay, so we have like 80 pins here, which isn't enough roundabout because you would need more than that for 128 inputs. We need more. We could use 204p gold fingers. How many differential pairs? Differential pairs would be nice. BGA 256, but okay. I'm wondering if yeah, I don't want like to place that. I don't want to make a BGA board. I just want to plug it in and be good, you know? I would even consider to using the Tang Nano 9K instead. Raspberry Pi 5 compute module. No, that's cheating. Bye the sheepoo. Wait, what is the Tang Mega? What is this? Ah, PCI Express. Yeah, as well. That's the P mod. One bank is 1.8 volts. Oh. So which one has 3.3 volts? Yeah, this has not enough. I like the 20K, and I have several of those. I have also several of the primer 20K. Primer 25K. Free expansion FPGA board. Oh, look at that. I like that. Two times 20 pins. Yeah, sadly not enough. I think no, it's not small. Wait, the module is small. Yeah, I can take 4 of them, or I don't know. Crowd supply FPGA tab. Hmm. Yeah, it's like 40 pins. $32. Yeah, it's just to process data maybe. Anyways, yeah, I think as well get. How do I purchase one? Yeah, not broken out. Uh, $30. Okay, single module, $15. Still alright with the RAM and stuff. PMODs. LED matrix. Oh, is this RAM? SD RAM, WinBond. Ah, interesting. Yeah. All right. What else did we want to check? Oh wait, we had 317. Wait, do we have some specs? USART, CAN, BOSS. They don't, the WCH don't support, I think, like octal SPI. We need like ESP. We could put on as ESPs the S3 modules to handle like octal SPI. They can do it in hardware. Where is the pinout of the main module? Where's the spec specification? It's downloading, it's downloading. Uranium. You get me some blue. Here. There's blue light coming from the LED. 10 milliamps. Okay, it's downloaded. I think I'm okay. Here we go. That might be a solution to process stuff. Okay, pin number. Pin name. Okay, we have more pins than we have VDD. Okay, there are some pins here. icebreaker, yeah. Oh, that's a rabbit hole. I see dying there. Okay, we have 48, 30. Let me check the specs. $75. That's good. Hmm. Okay. Does any of those? Yeah. Okay. Wait. No, that's C6. Huh? There is no tiny FPGA. Oh, that's based off the ICE 40. Yeah. AX and BX. Then we have Icebreaker is also iSpy 0. They're all ICE 40 based. But that would be, I can't cheat like putting like an actual computer on there. That needs to be, I just need something to digest data and transfer it fast. So the specs look, Johnny, the spec look quite nice here. What is the voltage level of the IOs? Is this all, that can't be, is this 3.3 volts all of the, or is it like 1.8? Ah, right. 3.3 volts. VCCIO. CIO. Oh, it looks like. Wait, VCC. Three lights on. Oh, damn it. There is no information on what's the range. Voltage range. Schematic. Pad chip. Part routing length table. Okay, interesting. I like that one. We have 64 PCBs. We might what's the clock speed is probably up to what did we have, internal clock of 600 megahertz on those, on the 10 nanos, even if it's like megabits. Logic, PLLs. Look at that. I like that. 1.25 gigapips. 1 point. What are you doing? 1 point whatever giga pips. We can do HD with one of those. Gigabits per second. LVDS. Is it per channel? MIPI DeFi hardcore 2.5 gigabits for data lanes. Mainboard provides for core board bank power supply. But what is the mainboard provides for core board. Okay, bank. Yeah, LVDS. Yeah, it is. Such signals. Yeah, this is what we actually need like length matching and differential pairs and everything with impedance. Not what we designed there with requirements of 14 kilobits per second. Microstrip, yeah. Alright, peeps. I think I had enough for today. I updated you on everything. We saw that this LED, this is our achievement of the day. Already, we are talking for 3.5 hours now. I have a dry mouth and my booster is gone. Are you sad? What else do we do? Yeah. We will have 24-hour streams and I'm not sure if this year. Aww, Johnny. Optical data bus along the edge. Yeah. Soldering the LED. Yeah, it's an RGB. It's not just an LED. Look at that. I give you the goodness and the good. Here we go. Should we try to short all the pins? No, won't. It takes shortest path. No, it doesn't do. It takes the shortest path, which is the red if we short them. All right. 24-hour fondue stream. Yeah, usually I need just some rejuvenation on a stream to do longer than 3 or 4 hours. Did you hear that? That was my Brustbein. What is Brustbein? Sternum. That was my sternum, peeps. It does that recently because I'm like sitting like that. Alright, peeps. Looking forward to the new streams. Looking forward to the PCBs. Let's update last time. Maybe it's already finished. Still profiling. Peeps, still profiling. But they're fast. Look at that. They said it will be 5 days, and we are like second day, and it's already done. Electrical test. This is like 1 more day, 3 days, and it will be shipped. Oh, it takes like, unfortunately, it takes like 8 days with Europacket because I was cheap on the shipping and I hate DHL. Next week, next week we won't have that. You know what we will do next week? I can tell you now. There's not enough time because we are talking too much this time and soldering one LED. I will show you. We will test this thing. These MCU. I never tried one of the 303s. We will put it on a breakout board. Brian! Happy New Year! Thank you for the resub. Yeah, I'll put it on a breakout board. You just joined at the end of the stream, Brian. Where is the breakout board? Here. Quad flat packs. Oh, thank you very much. Thomas. Okay. I will put it on GitHub. Wait. One shop. Yeah, on AliExpress. I can try to upload it. Wait. Git init. Wait, I can open this. Encode. New window. I will just open the whole repo here. Like that. It's not a repository. I trust the authors. Wait, here. Then I will initialize that. Oh, damn it, that's too much. New file. And this will be code RP 2350. I want to have this. Okay, now it's okay, cache files. 24 symbol table. I need to probably clean it up as well. Let me check. Oh. I have no clue which one. I think we looked at the A, or yeah, I think the A is the one that we checked. So I will exclude that. Can I exclude it? Add to git ignore. Oh. $45. Yeah, whatever. Okay. What do we have here? Cache. You say production. The log cluster backups, that's this one. Yeah. What else do we have? Symbol. Fabrication toolkit options is also something. Yeah. Whatever. It's private, but it's alright. I don't care. Cache. Oh, I have no clue. Symbol. Okay, let's see what we got. Easy EDA KiCad symbol. Okay, I can ignore that as well because that is just Test gewesen. Test gewesen, yeah. German. Mixed in German. Where is it though? Wait. There are different backups. Yeah, I can delete them all. I don't care about the backups though. I don't care. Also the production file is generated anyways. Yeah, this is JC pretty shapes cluster. What is that? Cache? We had that. KiCad schematic. Huh? Symbol. All right. And publish. Here we go. I have no clue how it's called on GitHub. Check that. The 800 CPU. Yeah, you can test that, Thomas. I see you next week then. Here are for the peeps who are interested in that not working. Oh, let me add the README. Yeah, okay, not working. So people who follow me won't be just ordering the board and failing. All right. Maybe I should add more info. Okay. Here we go. All right. That was that. I wanted to. Yeah, we have breakout boards for the MCUs here. I think this will be one of those. What is the pin pitch? Q quad flat back to dip. I think this is the right size. To be careful, but I don't know how many I have. But basically, oops. Yeah, that's the right pin pitch. I have even smaller. Yeah, you can see the interference pattern. We can use that, or oh, I think this is not dense enough. This is, yeah, that will be dense enough. I guess this is 0.4. Yeah. This will work as well. Not sure if I have ones that fit even better than that. Yeah, these are too small. Here's one package. All right, peeps. Thank you for joining the stream. I see you next week. And I hope we get our PCBs soon. And I will also order an assembled version. Probably next week then. Bye bye. Bye bye everyone. Thank you for joining. Thank you for all the resubs. And for the donations. Kaspar, thank you very much. That was generous. Also Fu, thank you very much. Till next Wednesday. And let's look at the LED. Woo, bye bye. Bye 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 bye.